In the early 1800s, the United States faced a pronounced economic disadvantage. Great Britain held a near-total monopoly on textile manufacturing, leaving the mostly rural American economy unable to compete with foreign industrial output. To close that gap, a Boston merchant named Francis Cabot Lowell traveled to England. He moved past the finished textiles to focus on the machinery itself, secretly memorizing the specific configurations of British power looms to bring those secrets back to the States. Lowell returned to America with those stolen schematics in his head. He teamed up with the Boston Associates, a syndicate of wealthy merchants who pooled their capital, to execute a radical plan. Instead of splitting up spinning and weaving across different locations, they would consolidate every single stage of textile production into one integrated system under a single roof. To power this large-scale operation, these investors needed an immense energy source. In the 1820s, they quietly bought up the farmland surrounding Pawtucket Falls. The falls were a 30-foot natural drop in the Merrimack River that provided the raw kinetic energy required to turn heavy industrial water wheels. By acquiring this specific stretch of the river, the investors engineered a prototype. They were building an entire, ground-up American industrial city. The physical hardware of this new city, named Lowell, was an intricate, miles-long network of hand-dug canals. These waterways acted like veins, routing the immense power of the Merrimack directly into a grid of 6-story brick mill buildings. Inside those mills sat the automated internal mechanics, rows and rows of synchronized power looms. A power loom is a mechanized machine driven by water shafts and belts rather than human muscle, replacing slow, manual weaving with high-speed, continuous production. But a machine that size requires software to run it, a reliable labor force. The corporation recruited young, unmarried Yankee women from New England farms, finding them to be a disciplined and highly capable workforce. To keep that workforce efficient and protect the company's public reputation, management applied a rigid layer of social engineering. The women lived in company-owned boarding houses, adhered to strict curfews, and followed exact moral codes governed by factory overseers. The mill workers maintained strong intellectual agency within this highly controlled environment. They attended lectures, formed study groups, and even published their own literary magazine. Through carefully designed physical infrastructure and strict social management, the Lowell experiment successfully integrated human lives into a highly profitable, high-output industrial machine. By the 1830s, the drive for higher profits introduced serious friction into the system. Management decided to speed up the power looms to increase production while simultaneously cutting the workers' wages. In 1834 and again in 1836, the female workforce collectively organized and staged turnouts. A turnout was an early 19th century term for a labor strike, where workers would shut down their machines and physically turn out from the factories into the streets to protest wage reductions. These early strikes were largely unsuccessful in stopping the wage cuts immediately, but they laid the groundwork for the organized American labor movement. To keep the mills running, the corporation updated its labor model. As the original Yankee mill girls left the factories, management replaced them with a new wave of highly vulnerable workers, Irish immigrants fleeing the Great Famine, a period of mass starvation in Ireland caused by consecutive potato crop failures. This influx was soon followed by French Canadians, Greeks, Poles, and Portuguese immigrants. As each new group arrived, they took their place on the factory floor and in the surrounding neighborhoods. The rigid corporate experiment designed by a few Boston merchants inadvertently evolved into a dense, complex, multicultural social hub that outgrew its original design. This map shows the systemic decline of the Lowell prototype in the early 20th century. You can see how textile manufacturing dominance migrated south as corporations relocated to exploit cheaper labor and environments with weaker labor unions. By the time the Great Depression hit, Lowell entered a silent era. The deteriorating industrial infrastructure, the miles of canals and giant brick mills, became an enormous liability, leaving the city in a decades-long state of economic depression. The pivot came in the 1970s. The federal government established the Lowell National Historical Park, testing a new prototype for urban renewal that relied on preserving the city's expansive industrial footprint rather than bulldozing it. Today, that preserved hardware serves an entirely different function. The original brick mills now house technology firms and art studios, while the modern campus of the University of Massachusetts Lowell sits directly alongside the historic canal system. The true innovation of Lowell is its capacity for a complete reinvention cycle. It proves that an industrial city survives long-term by adapting its core physical infrastructure to meet entirely new demands.
Thank you for watching. Please like and subscribe. It really helps us.